So here's an example that is 3 by 3. So we're going to do exactly the same thing that we did. It's just on a much larger scale. So let's take a look here. The reduced row echelon form, that's the form where the matrix has the ones and the zeros. When it's a 3 by 3 specifically, it's going to look like this. So it goes 1 0 0 0 1 0 and then 0 0 1. The ABC there would be your answers to X, Y, and Z. So similar, obviously, but we had to adjust it for a 3 by 3 as compared to a 2 by 2. Write the system as a matrix. So let's do that. Just again, it needs to be in standard form. When there are terms missing, so like in the second equation, there is no X, you need a 0 placeholder there, and then like there's no Z in the third equation. So you need to have the 0 there. Okay. And then we're going to solve the system in a similar way. It's just going to be a lot of maneuvering. But again, the goal is to get this equation into that reduced row echelon form, meaning I need to turn that into a 0, that into a 0. That is already a 1, so that's good. That's already a 0, so that's good. I need to turn that into a 1. I need to turn that into a 0. That's already a 0, so that's good. That needs to turn into a 0, and that needs to turn into a 1. Let me point out that you already have some of the things in the form that you needed. So this could be worse as we start working through this. Again, this could get more complicated provided those numbers weren't already set where they need to be. All right, then you can kind of follow along with what they're doing here. They took the so they took that B matrix and subtracted it by the first line, multiplied by 2, right? And that created that third line. So again, we're trying to get that number to be 0, which is how they got that to happen. Then the next thing they did was they added that line with 4 times that line, and that created that right there. Then they divided that line by 5, and you got the 0, 1, 0, and then 0 there. So essentially they got the 1 in that spot, so that's fine. Once you get it, you don't necessarily have to like lock in each row where it currently is. So in the end, this will end up being the second row, okay? Which is what they ended up doing on the next. They switched the G and the F, and now that row that they just created with the 1 is now the middle row. So yeah, now they're saying H now matches what it needs to be. Now we're going to work on the first and the third row. So go a little bit. So 2 times once you get that with the zeros, that then makes it easier to then work to get the other rows, because you can affect things without hitting the other numbers in the row. So 2 times that middle row, we're then going to subtract by this row here. And what you end up with here is the 0, 0, negative 1, which then all you do is multiply that to get that to be 1. So then you're going to multiply that, like I'm saying here, multiply j by negative 1, and now that becomes the third row, and that's locked in. Now we just need to work on that first row. So they take that first row here now is this row minus this row. That'll get you the 0 here. And now they take this row minus 2 times this row, and that gets you the 0 there. So now this is in that reduced row echelon form, and then 3, 0, 5 are going to be your solutions for X, Y, and Z respectively. And you can check it. by substituting 3, 0, 5 in for x, y, and z for each of the equations, they all check out. So that means 3, 0, 5 is your ordered triple solution of that linear system. All right, so let's try this together. So maybe try it on your own, and then you can check my answer. So the first thing we're going to do is convert that equation in that system of equations into a matrix. The first thing to note here is that third equation, not in standard form. So we're going to subtract the 2x to the other side. You end up with negative 2x plus z equals 0. So when I go ahead and write that in matrix form, the first equation is just 3 1s and then a 13. The next one, there is no x, so that would be a 0 placeholder there, and then y is 1 and z is negative 1. And then 3 is your constant. And then for the third equation, negative 2 is your x, 0 is your y, and 1 is your z. And then 0 is your constant. First thing I note here is I've got several things that are what they already need to be. So I got the 1s on the diagonal, and then I've got these 2 zeros. That's all good. So really I need to work on 4 things. That needs to be a 0, that needs to be a 0, that needs to be a 0, and that needs to be a 0. Everything else is already what I need it to be. First thing I'm going to do is just add these two together, and that'll create a new first row. All right, so what I'm going to end up with here is 1, 2, 0, and then 16. And then everything else I'm going to leave the same. So that got me one of my zeros. What I'm going to do next is, in order to turn this 2 into a negative, into a 0, I'm going to first turn it into a 1, and then that will allow me to work with it there. So I'm going to divide by 2 on that row, and then I get 1/2. 1, 0, 8, and then everything else will be the same. And the reason why I did that is now I can subtract. Actually, before I subtract, what I'm going to add these two together. And that'll create another 0 here. So I'm going to have that 1/2, 1, 0, 8. I'm going to hold that for the next part. My second row is now going to be the combination of the second row and the third row from the last matrix. So when I add those together, I get negative 2, 1, 0, 3. And then my third row is going to stay what it is. Negative 2, 0, 1, 0. So now I'm going to start up here now. But now what I'm going to do is I'm going to subtract the, so these ones I added, right? And then I'm going to subtract these two. Well, the first one by the second one, because I'm trying to get the 0 in that spot. So 1/2 minus negative 2 would be like 1 half plus 2, or 1 half plus 4 halves. So now that'll be 5 halves. 1 minus 1 is 0, which is what I wanted. And then that's a 0. And then the 8 minus 3 would be 5. And then the other row I'm not touching right now. So negative 2, 1. 0, 3. And then negative 2, 0, 1, 0. Now, in order to get that to be back to a 1, I'm going to multiply everything by 2/5 in that row. So now I've got 1, 0, 0, 2, and then it's negative 2, 1, 0, 3, and then negative 2, 0, 1, 0. So what we've got here, that first row is locked in, that's good. What I can do now, in order to, and what I'm going to try to do now is to try to get zeros here, here. So what I can do is I can just multiply that first row by 2 to make that the opposite of what needs to be there, and then I can add them. And then I can just revert back to that first row that I already have locked in. So I'm going to multiply this by 2, and then I'm going to add it with those. So let me just write that out. So we got 2, 0, 0, 4. You got negative 2, 1, 0, 3. Negative 2, 0, 1, 0. Now I can add. So I'm going to do 2 additions in the same step here, just because I'm running out of room. I'm going to add the first and the second row, and that'll be my new second row. I'm going to add the first and the third row, and that'll be my new third row. And then I'm going to revert my first row back to this one, because that's what I wanted anyway. So my new first row is going to be back to this one. So 1, 0, 0, 2. And then my new second row is going to be this and this added together. So 2 plus negative 2 is 0. 0 plus 1 is 1. 0 plus 0 is 0. 4 plus 3 is 7. And then my new third row is going to be the first row here, added with the third row here. So 2 plus negative 2 is 0. 0 plus 0 is 0. 0 plus 1 is 1. 4 plus 0 is 4. So your answer is, now that's in the perfect row, reduced row echelon form. So that means x is 2. That means y is 7. And that means z is 4. All right, so we can check our answers on that. I would pause before you try the next one. I'll work it out, and then you can come back and check your answers for that. So the first thing we're going to do here is convert this to the matrix. So it goes 1, negative 1, 1, 5. The next one goes 4. There is no y, so we need a 0 there. Then negative 1, and then 3. And then the last one, 0, for there's no x. 1 for y, no z, so a 0, and then negative 1. So what I noticed first is that that is a perfect row. It's just in the wrong spot. So simple first step is going to be just rearranging the rows that we already have. So my first row I'm not touching yet. My third row is now going to be my second row. And it's locked in. And then my second row will now be my third row. So at this point, we already know that y is going to equal 3 based on that. No, y equals -1, which again, I guess you could get from just seeing that. But anyway, so y equals -1 is already locked in. Next step is I'm going to add the first two rows together. And what that's going to get me is a 0 in this spot. So my new first row is going to be the first and second rows added together. So I go 1, 0, 1, 4. And then my other rows are going to stay the same. So 0, 1, 0, -1, and 4, 0, -1, 3. What I'm going to do now is add the first and the third rows together because it works out nicely. There's already a 0 here, so it's not going to affect the 0 that I just created. And then that -1 will add to that 1 and make a 0, which is what I want in that spot. So I'm going to add the first and the third rows together. And that'll be my new first row. So it'll go 1, 0, I'm sorry, 1 and 4 are going to add to 5. 0 plus 0 are 0, 1 plus -1 is 0, 4 plus 3 is 7. The other rows are going to stay the same. Okay, so now I got zeros where I want them. However, I turned that 1 into a 5. Well, I can fix that by just dividing by 5. And then the zeros will stay 0. So 5. So when I divide by 5, my new first row is going to be 1, 0, 0, 7 fifths. And it's okay, that's a fraction. So now that's locked in. I've got 0, 1, 0, -1. So again, that's already been locked in. And then I have 4, 0, -1, 3. So the only thing I need to really worry about here, well, I guess two things. I need to turn that into a 1 and that into a 0. So I'm going to do two things on this step. I'm going to multiply this by -1, the third row by -1 to get that to be a 1. And that'll take care of itself. That'll also turn this into a negative form. So what I'm going to do is I'm going to multiply the top row by a 4. All right, and then that'll get me a 4 here. So then I can combine them to get a new third row. And then with it being zeros here, I won't have to worry about that. And then I can just revert my first row back at the end. So doing those two multiplications, my new matrix is going to be 4, 0, 0, 28 fifths. Second row is untouched. Then my new third row is -4, 0, 1, -3. Got the 1 where I wanted it there. Now I just need to worry about this one, which is why I have these being opposite. So now I'm going to add the first and the third rows together, and that's going to give me a new third row. And then I'm going to revert just by dividing by 4 my first row back to what it was. So I'm going to rewrite that here. So 1, 0, 0, 7 fifths. My second row untouched because that's been good. 0, 1, 0, -1. And then my new third row is going to be this first row and this third row combined. So 4 plus -4 is 0. That's what I needed there. 0 plus 0 is 0, so that stayed good. 0 plus 1 is 1. That stayed good. And then 28 fifths plus -3. So if I have 28 fifths plus -3, common denominator would give me 15, -15. So now I've got 28 minus 15, which is 13. And then that's over the common denominator of 5. So I've got 13/5 in this spot here. All right. So what you're going to end up with is x is equal to 7/5, y is equal to -1, and z is equal to 13/5. I think what you're going to find when you check your answer here is the answers are in decimals, but they're equivalent, so that's fine. Only time you need to worry about that, I mean, for me, if this was paper and pencil, fractions are fine. On a practice, if it's asking for a decimal, then enter it as a decimal. If it's asking for a fraction, then enter it as a fraction. So just pay attention to how it wants it for our purposes here. It doesn't matter for notes. Okay, so this was a lot. We're going to split this lesson into 2 parts. So I'm going to have you do the first and second part right now. And then tomorrow we can do the third, fourth, and fifth examples. All right. So try to have this done by class time on Thursday.